FMT100, I know you're getting tired of me saying that. Good news is, this is section 4.4, electrical symbols and drawings. Uh, I know once again they're referring us to the dang textbook. Fine, we're just going to move to the next slide. Uh, I enjoy electrical symbols. This is where I cut my teeth on for getting into the trades, being uh, an apprentice, electrical apprentice, and then moving through the rankings and whatnot. So I really like electrical symbols. I'm very comfortable with them, and I'll just leave it at that. So they're giving a lot information. I love this. Electrical drawings convey circuit operation, wire size. Yes, there's a ton of that information. Keep in mind that same type of information can be easily conveyed and available also on like hydraulic and piping diagrams. So this is nothing like whiz bang, like, oh my God, it's just in electrical drawings. No, the same type of information, once again, is available and usually provided on the drawings for hydraulic and piping diagrams. It's just they're making a big deal of it here. I don't know if they're trying to suck up to me. I don't know, but I'll take it and run like hell, right? So depending on the drawing, yes, you can start looking at circuit operation, wire size, all this other stuff, but it depends on the electrical drawing. So we're going to move on to that one real quick. So one of the things you need to keep in mind, no matter what type of drawing it is, the components are drawn in their de-energized state. The big reason for that is this. If you are working on or if you are installing electrical systems, they are typically de-energized. In particular, if you are working on them for repair, they should be de-energized. So what better way to draw a system than to draw it the way everything is currently as it's being installed or worked on. So everything is drawn in the de-energized state. Where does this really become important? Relays and switches. That's the biggest one, relays and switches. So you'll have to remember that when things are energized, relays and switches change their state, and then different things happen. And depending on what drawing you use, you can see what goes on. So single line drawings, uh, pictorials, schematics, and ladder. So single line drawings are just that. A single line represents many conductors, and it gives an overview of the system. Most single line drawings are usually used for power distribution. So you'll see them typically uh, easily when the voltages for that system are usually 480 volts and above. And usually there are a few thousand volts for the distribution. Pictorials are, as the name kind of implies, they're pictures. And they're great because they give you the near precise location of components, usually, but it doesn't show how the components are connected 9 times out of 10. Now, what's nice about pictorials is because they give you the landmark where everything's at, you can use pictorials to plan out wiring pathways. So you can use pictorials to go, okay, I need a wire harness and wires to go to this component, and this is the way I'm going to run it. Now, once again, it doesn't show how they're terminated, where the wires go to what location. It just shows the wires going to the component. That's it. If you want to see where the wires are going, specifically where the wires are being terminated, hooked into the component, you're going to either need a schematic or a ladder diagram. Now, schematics are usually drawn so they emphasize the electrical connections, and it gives you a broad picture, literally, of what's going on. Now, with schematics, if you get comfortable with reading them, you can start determining a sequence of operation. But schematics, really big call to and claim to fame is for troubleshooting. It allows you to trace out lines relatively easy to see where things are going, specifically where the wire is going and what component is supposed to be at the end of that wire. Now, ladder diagrams will do the same thing. Ladder diagrams show where things go, but it's done in a much much happier. Happier. I'll say happier uh, configuration. Happier in the sense that everything is laid out very methodically. So all the components are done in strings. Each string, called a rung, is in between two power rails, and it because the way they are set up that way and drawn, it looks like a ladder, hence the name. Ladder diagrams are used extensively in relay logic and was one of the ways computer programs were first laid out. So there you go. You get a tie in there as well. So once again, here's our pictorial. Uh, really great once again for physical location, but not so much. They say termination points, not so much. Single line drawings, uh, overview. There's not a lot of detail. It gives you the major components and where those components would be used for isolation. So for electrical, it would be disconnects, transformers, that kind of thing. You can also have single line drawings for process. So if you've got the refinery. The refinery was a process. We had a single line drawing of the process, and we could, on that single line drawing, we could isolate particular parts of the process by the isolation valves. So those isolation valves were marked on our single line drawing, but the rest of the piping, the rest of the valves and the instrumentation was not represented on those drawings. So a single line drawing, while the claim to fame is electrical, as I just mentioned, it could be used for other types of processes as well. Schematic diagrams, once again, shows the electrical connections, does not show the physical locations of the components, and it's great to troubleshooting. You can determine how the system's supposed to operate, and when you get comfortable with them, but their big claim to fame is troubleshooting. And last but not least, ladder diagrams. Uh, it is a variation of schematic. It does show all the connections that are all the electrical connections, but all the components are laid out in a logical manner. As I said, everything that is used for one particular function is going to be on one of those strings. That string is going to be between the two rails, and that's going to be one rung. So that is where the ladder diagrams come into play. That is great when you're trying to troubleshoot what's going on with this relay and what all should be going on. So that's where ladder diagrams really come into play. You get comfortable with ladder diagrams, you can use ladder diagrams as a schematic and start doing your wiring from ladder diagrams. So I know I'm kind of leading you into FMT 104 and 105 with this section, which was kind of the point. All right, so that's it for electrical diagrams. We're going to add some filler to this, and we're going to do welding next, and that will finish off this unit, except for the lab. So hang on.